Let us see about the analysis of continuous time systems. After completing this course, the students can able to analyze the continuous time system using the Fourier transforms and the Laplace transforms. Impulse response, that is the LT system with and without memory. While we are seeing this convolution, the convolution is given by y of t equal to integral of minus infinity infinity x of tau into h of t minus tau into d tau, and the convolution is commutative. Therefore y of t equal to integral minus infinity infinity, this can be also written as h of tau into x of t minus tau into d tau. Here the continuous time signal is memoryless if the present output depends upon present input. Therefore the above condition is true for h of tau equal to k into delta, and therefore such a system can be formed by the memory system and can be given as y of t equal to integral minus infinity infinity h of tau into x of t minus tau into d tau. Here this is commutative, therefore we can just reverse this and write this equal to k into x of t convolution del of t. We know that x of t convolution del of t can be written as x of t, but therefore from equation 1 we can write this as y of t equal to k into x of t, where k is the constant and the system is memoryless and static if h of t equal to del of t, and this second condition is not satisfied, such a system is said to be the dynamic system. Hence the output is equal to the input and the system becomes an identity system. Next one is invertibility of LTI system. Let us consider the LTI system with impulse as h of t, and the system is invertible if it has a LTI system inverse system, and therefore the identity property is given as h of t in convolution del of t equal to x of t. Therefore we can also write this as the impulse response of the inverse system should also satisfy this condition, h of t equal convolution h1 of t equal to del of t. Next property is causality of LTI system. For a system to be causal, the output of the system must depend upon present and past input only. Therefore, h of t equal to 0 for t less than 0, and the convolution integrals becomes y of t equal to integral infinity to t x of tau into h of t minus tau into d tau. Therefore, this can be written as y of t equal to integral 0 to infinity h of tau into x of t minus tau into d tau. And the stability of LTI system property can be given as integral minus infinity infinity modulus of h of tau into d tau is less than infinity. Now we can go see in the Fourier method for analysis, that is the Fourier series response, the frequency response of LTI system can be given as y of t equal to x of t convolution h of t. While we are taking Fourier transform on both sides, this can be given by this equation. Therefore the convolution time domain gives the multiplication frequency domain, where h of j omega, it is the frequency response of the system, that is h of j omega equal to y of j omega by x of j omega. We all know that. While we are finding the magnitude, this is said to be the gain, and while we are finding the phase, this h of j omega is said to be the phase shift of the system. And next we can see the analysis and characterization of LTI system using the Laplace transform. While we are seeing this output of the system, this can be given as y of t equal to x of t convolution h of t. Therefore by taking this Laplace transform on both sides, y of s equal to x of s into h of s. H of s is the system function or the transfer function. Here we are substituting s equal to j omega, therefore h of s is the frequency response of the LTI system. Now we can see the first property, that is the causality. For causal LTI system, that is h of t equal to 0 for t greater less than 0. That is the ROC for a causal system is in the right half of this S-plane, and also the second one is the ROC of the causal system with rational system. It is the right half plane to right of the right side. And next property is the stability, that is an LTI system is stable if and only if the ROC of the system function h of s includes the j omega axis, that is nothing but the real part of s equal to 0. And also in the case of causal system with rational system function is stable if and only if all the poles of x of s lies in the left half of the S line. This is the first question. Thank you.